Okay, so this is lesson 2 for unit 3. So we'll get started here with some notes. Okay, so go ahead and copy those into your notebook. So we're going to factor completely. So the first one is just to demonstrate a point. I know it's very simple, but we're going to always start by pulling out the greatest common factor. So between 2x and 6, I know that 2 is the greatest common factor. So I pull that out. I thought we just did that, but I guess not. Okay, so we're going to pull out that 2. And then we're left with 2 times what gives us 2x? We know that's x. Plus sign 2 times what gives us 6? We know that's 3. Okay, now that was intentionally easy to demonstrate the process, to demonstrate the point that we look at this term and we look at this term. So everything in front of the sign and everything after the sign, and we're looking for what they have in common. So if I'm looking at this next one, which is obviously more complicated, but I'm going to approach it the same way. I'm going to, first of all, I don't see common factors just by quickly glancing. So I'm going to underline everything in front of the sign and everything after the sign. And then I'm going to compare the two pieces that I've underlined. Just like with the real basic one, I'm comparing what's underlined. 2 is in common in both. So here I'm looking to see what factors, what is being multiplied in both pieces that I have underlined. And if you look closely, you can see that x plus 1 is being multiplied and x plus 1 is being multiplied. So x plus 1 is the common factor. So just like I brought the 2 out front, I'm bringing the common factor of x plus 1 out front. Afterwards, I'm going to have parentheses after that. Just like here, after I brought the 2 out. Now, the 2 wasn't in parentheses there because it was a single number. It was a monomial, but I could put it in parentheses. Here, I have to put this x plus 1 in parentheses because it's a binomial. It's that whole entire expression, x plus 1, that I'm factoring out. So x plus 1 I factored out, and then again, up here after I factored out the 2, I was left with x plus 3. How did I figure that out? Well, I said 2 times what gives me 2x, and I knew x. Then I brought the plus sign down. 2 times what gives me 6? Well, I knew that's a 3. So that's exactly what I'm going to do here. X plus 1 times what gives me x squared times the quantity x plus 1? Well, it's going to be times x squared. Then there's a plus sign. Now x plus 1 is factored out. X plus 1, the quantity, gets multiplied by what to give me 1 times the quantity x plus 1? It gets multiplied by 1. So now I'm checking this x squared plus 1 to see if it factors. It's a sum of squares. There's no such thing as factoring a sum of squares. Therefore, that's my answer. The quantity x plus 1 times the quantity x squared plus 1 is the same as the factored form of the original. Okay. Next one. So go ahead and copy that. Once again, these don't look like any of the other ones we did yesterday. I don't see trinomials here. I don't see binomials here. I see common factors that are binomials. So when I see a problem that looks similar to that, like what we just did, I'm going to underline everything in front of the sign, underline everything after the sign. And I'm going to focus on the 2 underlined pieces and what I see in common, what's a common factor in both. So looking closely, I can see that x minus 5 is a common factor. When I factor that out, I'm left with x minus 5 is multiplied by y squared, and then I bring down the minus sign, and x minus 5 is multiplied by 9. So that's my first step. Now I see y squared minus 9 is difference of squares. So I'm going to keep the x minus 5. Again, that's in parentheses. And I'm going to factor y squared minus 9 into y plus 3 and y minus 3. Next. So go ahead and copy that. Once again, I see common factors, greatest common factor. I just have to identify what it is. So I'm going to underline everything in front of the sign and after. and I'm comparing what I just underlined. So I see x minus 3 is in both of those underlined pieces. So that means it's a common factor. This binomial x minus 3 is a common factor. So after I factor it, I have to figure out what it needs to be multiplied by. Well, x minus 3 has to be multiplied by what to give me this underlined piece? It has to be multiplied by x plus 6. So notice I put parentheses for after the x minus 3, and now I still kept the x plus 6 in parentheses. That's important that you have a double parentheses there. Now I copy the sign. X minus 3 times what gives me the second underlined piece? Well, it's times the quantity x plus 1. And now I'm done with what x minus 3 needs to be multiplied by, so I'm going to end those parentheses. Okay? And if you look at that carefully and slowly, you'll realize that's correct. I pulled out the greatest common factor, what was underlined, what was in both underlined parts, x minus 3. After I factored it out, I was left with x plus 6, and then plus, and then x plus 1. So now I'm ready to simplify this further. And what I'm noticing is, well, I have plus 6 plus, I have x plus 6 plus an x plus 1. I'm adding. So that's just combining like terms. So x plus x we know is 2x, and 6 plus 1 we know is 7. So that simplifies to 2x plus 7 after I combine like terms. Now I'm checking to see if anything factors. I see that it doesn't. So that is my final answer for the factored form of the original. Next, another one which looks similar again. Underline, underline. Look to see what is in common in both pieces that are underlined. I see x minus 2. I put that in parentheses. I put parentheses after it, and I'm going to go one underlined piece at a time. So I'm focusing on this first one. So, and it has to go in that order. I have to do the one on the left first minus the one on the right second. So x minus 2 is what I factored out. When I factor it out, I'm left with parentheses x plus 4, parentheses. Then there's a minus sign. Now I'm done with this first piece here. So now I'm looking at the second underlined piece. X minus 2 was factored out, which leaves me with, in parentheses, 3x plus 8. And then I'm going to end the parentheses. Again, if you double check that, x minus 2 times x plus 4, I do get the first underlined piece. X minus 2 times 3x plus 8, I do get the second underlined piece. And there's a minus sign in between. So now I keep the x minus 2. And I'm going to combine like terms here inside the parentheses. So I have x minus 3x, which gives me negative 2x. And I have 4 minus 8, which gives me negative 8, or negative 4. Sorry, negative 4. 4 minus 8, negative 4. So now I have to check to see if that factors any further. And I see that the x minus 2 doesn't, but the negative 2x minus 4 does. I can pull out a negative 2. So negative 2 times x plus 2. And I can double check that. Negative 2 times x, negative 2x, negative 2 times positive 2 is negative 4. That's correct. Now you can either leave it that way, or generally we put the number in the front. And if I do that, if I put the number in the front, I don't need the parentheses anymore. I can just leave it as negative 2. It's not wrong if you keep the parentheses around it, but you don't need it if you put it in the front. Okay. Now, if I kept it in the middle here, I would want to keep the parentheses around it because it's negative 2, not subtracting 2. But in the front, I can leave it without parentheses or with. So that is my final answer. Okay, looks like we have another one here. So once again, underline, underline. I'm looking to see what's in common. There's actually a couple terms in this one that are in common. So we'll take them one at a time. I see x plus 1's in common. Now, one is squared and one is cubed. In common, the highest that they have in common would be the squared, because, excuse me, I can't say that they have a cubed in common because only this one's cubed. So squared is the highest they have in common. They also have an x plus 4, and I'm comparing 2 versus 1. The highest that they both have would be a 1. So I can either just leave it as x plus 4 or put to the first. Either's fine. So that is my GCF. Now I need parentheses after the GCF. So I'm going to look here at the first underlined piece. Excuse me. So x plus 1 is already squared. That's what we pulled out. X plus 4 is to the first, but we need it to be squared, which means I need an additional 1x plus 4 to the first power. Now I have, if I multiply this GCF times this, I do get the first underlined piece. So I'm ready to move on to the plus sign. And now I'm focusing my attention on the second underlined part. So I have x plus 1 squared, and I need x plus 1 cubed, which means I need an additional x plus 1 to the first power. Because x plus 1 squared times x plus 1 would give me x plus 1 cubed. And then I have an x plus 1 to the first, and that's all I need. So I don't need to add an additional x plus 4. So I'm ready to end my parentheses. So now I have x plus 1, the quantity squared, and x plus 4, which I'm just going to leave that as x plus 4. And now I'm ready to combine like terms inside the parentheses. So I have x plus x, which is 2x, and I have 4 plus 1, which is 5. And 2x plus 5 does not factor. So this is my final answer. Okay, next. So we have this problem to factor, and there is no GCF, no greatest common factor. But what I do have this time, this looks a little different. There are 4 terms. When there are 4 terms, what you will do is use a technique called factoring by grouping. And what that means is that you'll group the first 2, pair them, and you'll pair the second 2 terms. Then what you'll do is you'll look at the first pairing and you'll pull out the greatest common factor. So between x cubed and 3x squared, x squared is the greatest common factor. When I factor that out, x squared times what is x cubed? That's an x. Plus sign, x squared times 3 is 3x squared. Now, if factoring by grouping is going to work, then this second pairing will also have that same binomial x plus 3. So I'm just going to immediately copy it, because I know that if factoring by grouping is going to work, then it's going to be the same binomial. So now I have to see if it's going to work or not. Is there something I can multiply the quantity x plus 3 by to get negative 4x minus 12? Yes, there is. It's a negative 4. Negative 4 times x, negative 4x, negative 4 times 3 is negative 12. So I know that this technique of factoring by grouping is going to work. If it didn't, if I had something like negative 4x minus 13, let's say, then I copy that x plus 3. Well, there's nothing I can multiply 3 by to get negative 13. So then I would know, oh, can't use that technique. This one doesn't factor. But this does, because we were able to pull out that negative 4. So now I have a problem similar to what we did before in the last several examples. I have a term, minus sign, and then a term. So I've underlined. Now, what I see in common is the x plus 3. What I'm left with after factoring out that binomial, I'm left with x squared minus 4. That I can see as difference of squares, so I'm going to factor it using the difference of squares technique. And I'm finished. Same thing here. Check for GCF. I don't see a GCF. Well, actually I do. I see a 2. I could pull a 2 out. But I actually don't even really need to. I could pull a 2 out or not. But what I am going to do, because there are 4 terms, is I'm going to group. Now I'm going to pull the GCF out. Not such a big deal to pull it out at the beginning because I'm going to do it right now. Looks like 2x squared. And that leaves me with x plus 2, which means this is going to be x plus 2 if factoring by grouping is going to work. And it looks like it will because when I multiply that by 2, I do get 2x plus 4. So now I have the piece in front of the sign, the piece after the sign. I'm looking at the two underlined pieces, and x plus 2 is the greatest common factor, which leaves me with 2x squared plus 2. Okay. Now, don't see anything common here, but I do see a 2 in common there, so I know that I have to factor that further. Or had you factored out the greatest common factor of 2 at the very beginning, then you wouldn't have to do this step now. You would have already done it. But we're going to factor out that 2, and that leaves me with x squared plus 1 when I factor it out. So I'm going to put the 2 in the front times the quantity x plus 2 times the quantity x squared plus 1. And that's my final answer. Okay, here's another one. So again, we're going to group, GCF, 4x squared. We're left with x minus 1. So this is x minus 1. Is there something I can multiply the quantity x minus 1 by to get negative x plus 1? Yes, it's a negative 1. And I would be careful to write the negative 1, not just negative, because it is a negative 1 that we're multiplying. That's going to become important in the next step. I'm underlining. I see x minus 1. And then I'm left with 4x squared minus 1. Now, if you had just written minus here and not minus 1, you may forget that that's a negative 1, and you may just write 4x squared in parentheses and forget about the minus 1 on the end. So that's why I say be careful with that. It's a negative 1 that you factored out. So it's a 4x squared minus 1 that's left. So now I have the GCF x minus 1, and I see difference of squares here, 2x plus 1 times 2x minus 1. And that is my final answer. Okay. Now, that's it for the lesson for today. So homework for tonight, you're going to do all of page 1 in the Unit 3 packet.